Statistics is the science of conducting studies to collect, to organize, summarize, to analyze, and draw conclusions from data. For example, in sports, they give the number of hits a baseball player receives in a season. In medicine, they often talk about the number of people catching a new flu virus in a certain year. A variable is a characteristic or attribute that can assume different values. For example, we could let X represent age, and that would be the ages of all students in the class. And I believe the class is very diverse when it comes to age, but age is a random variable since it is determined by chance. A data value, or a datum is a value that a variable can assume. For example, if I chose 5 students in this class, I may select a 21, a 18, a 24, a 30, or a 19-year-old student. All of these numbers would be considered data values or a data set together. There are 2 types of statistics, and we will go over both types this semester. For the first half of the semester, we will deal with descriptive statistics, and then for the second half, inferential. Descriptive statistics is the collection, organization, summarization, and presentation of data. And that's when we actually calculate, and we're going to use our calculators a lot in the class. For example, I may wish to find the average age of a Campbell student. It would be very difficult because we have a very large population of Campbell students, but it could be done. A population is the group of all subjects that are to be studied. A population's not always practical. It's often too large, too expensive to study for practical purposes or statistical calculations. So we study what we call a sample instead. So the entire student body of Campbell, and that includes graduate school and distance education students, extended campus students, would be too large to study. So we may want to sample the entire population and study the sample instead. And that would be easier to observe. For example, your class is a sample, and we could just take your ages, and based upon the average age of students in your class, we could predict that the average age of all students at Campbell is a certain age. However, taking just your class may not be the very best sample to take. Your class is not representative of the entire student body. I don't think we have very many distance education students in the class or graduate students in the class. So it may not be the best sample, but you are still indeed a sample. Inferential statistics we will focus on the second half of the semester, and that deals with the branch that deals with the generalization from a sample to a population. This branch will be covered in the chapters on confidence intervals and hypothesis testing. So based on the average ages of students, or the average age of students in this class or your class, we can predict the average age of all college students at Campbell University this semester. Variables can be categorized as either qualitative or quantitative. And then quantitative can be broken down into either discrete or continuous. Qualitative means that a variable can be placed into a category according to a characteristic: gender, male, female, religious preferences. I believe you know the very many religious preferences that we have in the world, based upon where people live, geographic regions. Quantitative associate a number or a numerical value. And they can be broken down into either discrete or continuous. If a quantitative variable is discrete, that means it's countable. It is a whole number like 0, 1, 2, 3. Number of students in the class. I have 60 students, not 60 and 1/2 student. You cannot have half a person. So that would not make sense at all. Continuous variables are measurable. For example, weight and temperature and time and length. So they are measurable. Measurement scales are perhaps the most difficult terms to learn in the particular chapter on vocabulary. And I will say that they are in order of nominal, ordinal, interval, and ratio, and they do build. So nominal classifies data into groups that are mutually exclusive. There's no overlapping, there's no order, there's no rank. For example, gender, male versus female. You're not supposed to say that a female is better than a male or a male is better than a female. Eye color, blue, brown, green, hazel, there is no rank, there is no order. Ordinal, it does classify data into groups that can be ranked, but there is no precise difference between the ranks. An example that I have is a restaurant example where we all as a class may attend the same restaurant, and at the end of the experience I ask you to rate your food or your dining experience as poor, good, excellent, and this is based upon personal opinion. We do not have a rubric to go by, so therefore it is ordinal, and that's when we do not have a pre-existing scale to judge the restaurant. A restaurant critic would have a rubric. So that is very different from us as a class when we would just give our personal opinion. A food critic would go by an actual rubric, and it would not be ordinal for a food critic with a rubric. Interval ranks data with precise differences, but there is no true zero. SAT scores, IQ scores, and temperature are examples. And in ratio, there are precise differences, and now we have a true zero. Height, weight, time, age, and salary. The mnemonic device that I like to use to help students with these 4 terms, and I'll put it on my document camera, NOIR, and I have an arrow saying that it builds all the way from nominal, where there is no order, there is no rank, like gender and eye color, all the way up to ratio, where we do have order, we do have rank, and a true zero exists, so they build. And my students quickly discovered that this is also a body wash found at the famous Bath & Body store. And I do love the Bath & Body outlet, and I frequent that store a lot. And I actually have an image of the bath wash on Blackboard if you'd like to click on the pic and take a look at it. Also, a student shared with me that in French, it is actually a word and it means the color black. So I just thought it would be something I could use as a mnemonic device. I did not even know it was an actual word. And you know my accent is very southern, as you can hear in this taping, so I am not going to try to speak in French and pronounce this word. Rather, I would just say use it as a mnemonic device, So, types of sampling. There are several types of sampling. We always wish to take the very best sample, and we hope that they're random. And I think you understand what it means to be chosen at random. For example, you number each subject in a population, place the numbered cards in a bowl, and then mix them up. Finally, select as many cards as needed for a good sample. Systematic, you don't take every subject in the population, but you select every 5th subject or every 10th subject. Here, very general, I say kth, if I'm pronouncing that correctly, but I mean to replace that with every 2nd or 3rd or 4th or 5th subject. For example, in a factory, you wish to test CD players in an assembly line. You may not wish to check every single CD player, but you're going to test every 5th CD player to see if there are defects. Stratified reminds me of layers. And so when I think about stratified, a population is divided into groups, and then a sample is taken from each group. For example, here at Campbell, we have freshmen, sophomores, juniors, and seniors. Cluster sampling is the most difficult for me. It is a population that's divided into groups called clusters by some means of geography. To receive a sample, a certain number of clusters are randomly selected. Then all subjects in the clusters are studied. I have an example of cluster sampling, and it says that a mayor of a large city wish to survey apartment dwellers. Suppose there are 10 apartment buildings total. The mayor randomly selects just 2 of the apartment buildings for study, and those would be your clusters. And then all the tenants in the 2 buildings / clusters would be surveyed. Convenient sampling is my very favorite, and it is based upon convenience. It's not always the best sample to take, but it is very easy. For example, a researcher stands outside a local mall and selects the first 25 people leaving the mall to interview. The researcher asks why the people come to the mall and the nature of their visit. It's not the best sample because the survey may be taken at a specific time of day, that not all customers entering the mall have an equal chance of being selected. Another example is here at Campbell, going back to the idea of finding the average age of a Campbell student. Maybe the sample that I take, I'll stand outside of Marshbanks, and I will survey the first 25 students leaving Marshbanks on a given day at lunch. And I will ask each student his or her age and record. And that way I would be taking a sample of 25. I could also stand outside of the library here at Campbell, maybe 9 o'clock at night, and survey the first 25 students leaving the library. Again, it may not be the very best sample to take, but it is a very easy sample to take. Last but not least, I wish for you to know the difference between observational study and experimental. Observational is, like it says, it's based upon just mere observation. Experimental involves a little bit more work. A researcher actually manipulates one of the variables in a study and tries to see if it affects the other variables. Usually there's a control group, a treatment group, there's a laboratory involved. Subjects were randomly assigned to 2 groups, and one was given an herb and the other a placebo. After 6 months, the number of respiratory tract infections each group had were compared. So that would be experimental, but observational is a little bit less involved. For example, a researcher stood at a busy intersection to see if the color of automobile that a person drives is related to running red lights, and that's just based upon mere observation. What I encourage you to do in this particular chapter is to go to, of course, Blackboard, do the Blackboard homeworks. Also, you may want to give your Connect Math practice a try. You could do the practice sets instead of the quizzes, and the practice sets are in blue. You could also do the self-taught learning units if you need more practice. And then take a look at the practice test, and you'll see the types of questions that I'll be using in the actual class. The other thing you could do is always go to your textbook, and this is your textbook, and work some of the exercises. For example, and I'll do some of these in class as part of class lecture. You could go over number 6, and you could list it as inferential or descriptive statistics. So on a test, I'll give you an example, and you have to tell me if it's inferential or descriptive. Same deal with question number 7. Question number 7, I ask you if it's ratio, ordinal, interval, nominal, and so you could read these examples and discover. I have the teacher's version of the textbook, so you can see that the answers are already there. So several of these exercises, and this is on page 26 of this particular textbook, will give you lots and lots of practice. Question number 12. List it as random, systematic, stratified, or clustered. Again, that's the best way to study for the chapter, is just to do the exercises. So I'll give you an example, and you have to tell me, is it cluster, systematic, random, stratified, etc., etc. And that concludes the lecture for Chapter 1, Definitions. I strongly recommend you do the extra practice on Blackboard. The next lecture will involve averages. And so stay tuned. I will be recording that lecture very soon. So I hope and every one of you have a blessed day and study those definitions. Bye-bye.